In this video, we're going to discuss the basics of activity tables, and in particular, the use of activity tables to list activities that form part of a project. Okay, so this is one of the applications of networks that we could actually use the network to help manage a project from start to finish. We have activities here that have to be done in a certain order. What you'll notice is with an activity table, there's typically 3 columns. You list the activities. Okay, so each of these activities could mean something. So if we're talking about making a cup of coffee, which is a project, what are some of the things that are involved in making a cup of coffee? You know, we've got to fill the kettle with water. We've got to boil the kettle. Get the cup ready with the coffee and the sugar. We pour the water into the hot water into the cup. Add the milk, stir it, and then enjoy the coffee, right? So that could be an example of a project. What we're going to focus on though is we're going to build or draw our weighted directed network, okay, based on the information given. So this is just some random table I came up with just for the purposes of this video. We talked about these 3 columns here. The first column is activities. Okay, the second column is called the predecessor column. Another way to think of the predecessor is what activities have to happen first before the activity in the first column can take place. So for example, activity C can only take place once activity A and activity B are completed. So another way we can think of the word predecessor, we could replace it with depends on. Okay, so C depends on A and B. D depends on C. E depends on A and D. F depends on E, and so on. And then the last column is a time column, a time cost. So each of these activities will take a certain amount of time. So it could be minutes, hours, days, weeks. It doesn't really matter. It's just indicative, whatever the time is, whatever unit of time we use. So, okay. Now, you notice at the first row, the predecessor is just a dash. That means that from the start, A and B are the starting activities. So the way we draw that, now hopefully I'll have enough room here. So I'm just going to draw just a starting vertex here. So we're going to call this the start. Okay. And another thing when we're drawing the network diagram is that it's edge based, not vertex based. The vertices only really indicate the start and end of an activity, but the activity itself is indicated by an edge. So let's draw in A and B. So we've got A and B. Okay, and we draw in an ending or an end vertex. So I'm going to write the activity or label the activity in red. And so that's activity A, and it takes 3 minutes or 3 units of time. This is activity B and needs 5 units of time. Okay, what I like to do as well is I like to just indicate that I've actually drawn in these activities in the diagram. So A and B, we've already covered those. Let's have a look at C. Okay, C depends on A and B. So I could draw C here, for example, between these 2 vertices. Okay. And C requires 2 units of time. But we have a bit of a problem. C also depends on A. Now, one of the rules with drawing a weighted directed network, and especially when it's to do with activity tables, we're not allowed to have multiple edges. So if you recall, remember multiple edges? So you could have 2 vertices and multiple ways of getting between these 2 vertices. I'm not allowed to have that at all. Okay, so that's one of the rules of this particular idea. Sort of the drawing the network diagram based on an activity table. No multiple edges. We need to introduce something though to help us though in this case. How do I join A and B together without creating a multiple edge? We use what we call a dummy activity. Okay. A dummy activity doesn't do anything at all. In fact, it's got a weight of 0. So we don't add this in terms of its weighting, or doesn't contribute any extra time or anything like that. So that all this means is that C depends on both A and B. That's all that dotted line is there to indicate. That's it. Okay. All right. So C is done. So we can put a little dot there to say we've done that. D depends on C. So that's fine. So I might just put D between these 2 there. Okay, so D depends on C, so that's D, and 6, it needs 6 units of time. Right, now E depends on both A and D, so A and D. So I might just put E here somewhere, okay. So I'm just sort of running out of space. Usually I go from left to right as much as possible, but in this case, sort of limited for space here. So we've got, this is activity E. E depends on A and D, okay? So, but A has to join up here as well, okay? So since you've got two vertices here that are predecessors, okay, so E depends on both of those. Look, I would probably advise that you draw your diagram in pencil. It's possible to probably rub out an edge and redraw it somewhere else. But if need be, you can introduce another dummy activity, okay? Doesn't make it incorrect, it just means that the diagram possibly has more dummy activities than are actually required, than the minimum required. So I'm going to join A to this vertex here. Okay, so there's another dummy activity there. Sorry, it should actually be a dotted line. Okay, so there's my eraser there. Okay, so there's another dummy activity. So E now is drawn correctly, and it depends on both A and D being completed. So I can put a dot there to say, yep, all done. Now we've got two more vertices. So we've got F. F depends on E. Okay. But then looking forward, because I'm running out of space here, G depends on both C and F. So C and F, and then G is really our end vertex, you know, our end activity. The vertex that's at the end of G is the end. Okay, so maybe what I might do is I might draw F here. Okay, probably in hindsight I should have probably drawn E maybe down, but that's okay. In fact, what I might do is I might just put that E there. Yep, I think that's a little bit better. All right, sorry that the diagram's a little bit okay, just not my ideal diagram, but anyways, I just have to make use of the available space on this little whiteboard. So this is activity F, okay, and that costs 1 unit of time. All right. Now the final one here is activity G, which depends on both C and F. Okay. So there's maybe I might just draw this. So this is really our end vertex. Okay. And okay, so this is activity G, and this needs 4 units of time to complete. However, it also depends on activity C as well. So I could put in a dummy activity. Sorry, drew it wrong there. That should have been probably thinking, you made a mistake. That's all right, just testing. Okay, I might just fix that diagram. See why pencil's so important? Okay, well, I'm using a whiteboard marker, so I'm going to draw a dummy activity there. Okay, hopefully you can see that. And that will be our completed network diagram. So let's just quickly trace over it. F depends on E. Okay, so I think that's correct there. Yep. And takes 1 unit of time. G depends on both C and F. So I could draw G after F, okay, but C also is needed. Okay, in other words, we cannot complete G unless C's, we can't start G really unless C is completed. So I drew in a dotted line, a dummy activity from C to the start of G, and this basically represents what's in the last row of this table. Okay, hope that all makes sense. I know it might sound a little bit complicated with all these dummy activities everywhere, but really it's just honestly just follow the table 1 row at a time, and put in the dummy activities where need be. You try and avoid them where you can though. So if it's possible that two vertices can sort of come together, not create a multiple edge. As long as there's no multiple edges, then you can join 2 activities at 1 vertex. That's not an issue, provided you don't have a multiple edge. Okay, sorry I've stressed that a few times, but very, very important. Okay, thank you for watching and wishing you all the best.